Good morning. Today we're working on two-step problems about a fraction of a group. Now we've done this before, both the easy way and the longer way. So today this is kind of a review, but I'd like to just go through a paper with you that's not in your book, but will help you do the problems that are assigned to you today in this lesson on page 663 in your book. So later on, you're going to be doing page 663. You're going to be doing letters A through C on the lesson practice. Okay? So two-step problems about a fraction of a group. Sometimes it takes two-step operations to find a fraction of a group when the total is known. So the first thing would be to divide by the denominator, which is the bottom number of a fraction, to find the number in one part. And then we multiply the numerator, the top number of the fraction, to find the number in more than one part. So here's the rule to remember. Remember the rule we use to find a fraction of a group. The number in each group times the number of groups equals the total. So here's an example. I know when I read all this stuff, it kind of sounds like seagulls flying at the beach, and it doesn't kind of make sense until we start looking at the examples. So don't get nervous quite yet. At a concert, 7/8 of the audience, remember when we did those problems before, 7/8 of the audience wore wristbands. If there were 5,600 people or 5,600 people in the audience, how many wore wristbands? So sometimes you would see that I would ask you to write it in a problem like this. Remember when we did these? Of course, we were doing most of them that did this, 1/8, and then we knew we did this number divided by this number. Okay, do you remember that? Okay, so today we're taking it to the next step. Instead of having a 1 on the top, we have 7/8 of the audience, and the audience was 5,600. So this is the problem I would be looking for on your paper to start out with to tell me what this word problem is really asking. Then you could turn it into a division problem. Well, I'm trying to show you right now that we can do this. 56 divided by 8. What's 56 divided by 8? Well, we know 56 divided by 8 is 7. And there's 2 zeros here, so we can do the answer as 700. Just like they did it the long way, but we can just kind of do that in our head. So we're dividing the total, that's this, remember that's the audience, by 8, that's the bottom number, the denominator of the fraction. But we have to take it one more step because we took care of the 8, but we still have this 7 up here. So what we have to do is take this first answer and multiply it by the top number, which is 7. Of course, I can look right here and do 7 times 7 is 49, and my 2 zeros. And there's my final answer. They did all this to do a short problem like this. We're going to do 2 examples. Here we go. 2/3 of the 21 students wanted to play kickball. How many students wanted to play kickball? So if I was asking you to write that problem, it would have looked like this originally, 2/3 of 21, which really means I'm going to do 21 divided by 3. 21 divided by 3 equals, right, 7. That takes care of the bottom number and this number. So I have 7 to start out with. So my next step would be to take this number right here times this number right here. 7 times 2 equals 14 students. So there's your answer. The next one, 3/5 of the 55 beads of 55 equals, okay, so our first step is to do 55 divided by 5 equals, well, what number times 5 is going to get me to 55? 11. I'm going to take this number times this number next to get my second half. Okay, and I'm going to get 33. So 33 beads were not purple. You know what? I didn't even finish reading that first sentence. I was so excited to solve the problem, but it said 3/5 of the 55 beads in Miss Cavender's necklace were purple. How many were not purple? 33 beads were not purple. So we have to remember also to put our labels on there if it is a word problem. All right, you're going to have fun doing those problems on page 663, and you're just doing letters A, B, and C. That's what this line means, A through C. So you're going to do A, B, and C. All right, good luck.